Section 1.2, Number Patterns. A number sequence is a list of numbers having a first number, a second number, a third number, and so on. The nth term of a number sequence is the last number in the sequence. In an arithmetic sequence, the nth term is obtained from the n minus first term. You find the next term by using the one before it, by adding some fixed number called the common difference. Example 4, 7, 10, 13. The common difference is 3. The next term, add 3 to the 13, would be 16. In a geometric sequence, the nth term is obtained from the n minus first term. You find the next term by looking at the one before it and by multiplying by some fixed number called the common ratio. Example 2, 10, 50, 250. Each time you multiply by 5. The common ratio is 5. Each of the following sequences is arithmetic or geometric. Determine its type and find the next term. 5, 10, 15, 20, 25. You can see there's a common difference between each of them of 5, so it is an arithmetic sequence. The common difference is 5. The next term is 30. 3, 12, 48, 192, 768. You can see there is a common multiple of 4. So it is a geometric sequence. Multiply by 4. The next term is 3072. We use the method of successive differences and come to sequences that are eventually arithmetic. 2, 6, 22, 56, 114. And what is the next term? Look at the differences between these terms. 4, 16, 34, 58. What's the next one? 12, 18, 24. We found the differences again. 6, 6. Next difference there is 30. 80. We have to do 114 plus 80 to find our next term, which is 202. Add 30. Add 88. The next term is 202. Use the method of successive differences to find the next term. 14, 22, 32, 44. And then what's the next term? First find the differences. 8, 10, 12, 14. Differences of 2 each time. 44 plus 14 is 58. Oh no. 5, 15, 37, 77, 141. What is the next term? Look at the differences. 10, 22, 40, 64. 12, 18, 24. 6, 6, add another 6, and then we find our difference is 30. 64 plus 30 is 94. 141 plus 94 is 235. The next term is 235. Sums of finite integer sequences and figurate numbers. Summing the first n natural numbers. For any counting number n, the following are true. 1 plus 2 plus 3 all the way up to n, that sum squared is the same as the sum of their cubes. And the sum of the numbers up to n is equal to n times n plus 1 divided by 2. Find the sum of all the counting numbers up to 100. 1 plus 2 plus 3 plus n is equal to n times n plus 1 divided by 2. In this case, n equals 100. 100 times 101 divided by 2. Multiply 10,100 divided by 2 is 5,050. Find the sum of the counting numbers up to 200. There's our formula, n times n plus 1 divided by 2. Substitute 200 times 201 divided by 2. 40,200 divided by 2. 20,100. Summing the first n odd natural numbers. Example, find the following sums of odd integers. 1 plus 3 equals 4. 1 plus 3 plus 5, 9. 1 plus 3 plus 5 plus 7, 16. 1 plus 3 plus 5 plus 7 plus 9, 25. 1 plus 3 plus 5 plus 7 plus 9 plus 11, 36. Do you have a guess for 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13? What's your guess? 49. To find the sum of a list of odd integers, the sum of the odds equals n squared. 2n minus 1 is our representation for the last integer in the list. 2 times any number is even, minus 1 gives you the odd number. To find the number of odd integers from 1 to 17, we need to know how many odd integers there are from 1 to 17. So we're going to solve the equation 2n minus 1 equals 17. Solving that equation, 2n minus 1 equals 18, n equals 9. So find the sum 1 plus 3 plus 5 all the way up to 17. Using that equation, that last odd integer, find the number of odd integers and square it. There are 9 odd integers from 1 to 17. So n equals 9. 9 squared equals 81. Triangular numbers. A triangular number counts objects in the shape of an equilateral triangle. 1, 3, 6, 10, 15. The nth triangular number is found using the formula n times n plus 1 divided by 2. Find the 7th triangular number using that formula, 7 times 7 plus 1 divided by 2. 7 times 8 is 56. 56 divided by 2 is 28. The 7th triangular number equals 28. A square number counts objects in the shape of a square. The formula for the nth square number, s sub n, the square number, is found by taking the number and squaring it. S sub 12. What is the 12th square number? 12 squared, 144. That's section 1.2, number patterns. Where's my mouse?